Hello, everyone. So in this video, I want to discuss addition and subtraction of fractions. I'm going to start with addition of fractions. So with addition of fraction, we're going to look at common denominators. And what I mean by that is, let's say I have 1/5 plus 2/5. Now, if you look at the denominators, you can see that they are all the same, right? So we say these are common denominators. Common denominators. So these two fractions have a common denominator, and that's 5. Now, anytime you have a common denominator, well, that works fine because to solve this, you have to put on the same denominator, 5. And then you're going to add the top. And we're adding the top because it's an addition problem. We've got 1/5 plus 2/5. So 1 plus 2 gives me a 3. Boom, I'm done. 3/5. All right, another one. So let's say we have 1/7 plus 5/7. Again, you've got a common denominator, so you've got 7, and then on top, you've got 6. Yay! Boom, you're done. So with common denominators, it works very well by only looking at the numerators. Just look at the numerators and then you're done. Now, this also applies to subtraction. So let's quickly look at subtraction, and we are only going to look at common denominators for subtraction. So let's do it. So subtraction, let's say you've got 5/7 minus 3/7. Okay, again, because we've got common denominator at the bottom, we're going to say that we are only looking at the tops, but before that, we've got to write the 7 at the bottom, and then we have 5 minus 3, which gives a 2. Boom. So, addition, subtraction, common denominators, same thing. You're doing the same. Only that you've got to remember that you're subtracting, so you have to minus. You're adding, you have to plus it. So that's it. All right, now let's move another step. This time we want to look at when you do not have common denominators. So I'm going to start again with addition. So this time I don't have common denominators. And that's why it gets a little tricky. So let's say I've got 1/3 plus 3/4. So if you look, you can see that we don't have common denominators in this problem. So what do? This is where you are going to use you're going to use the least common denominator or the least common multiple for these two denominators. If you've not watched the video for least common multiples, please watch it. It's going to help you. It's going to help you to solve these problems. So here we're trying to find the least common denominator for 3 and 4. So I'm going to start with 4 because if you remember in the video that I made, I showed you that it's always better to write out the multiples for the bigger or the biggest or the largest number. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and then it keeps going. You don't have to write out the 3. So now you're going to compare it. Will 3 go into 4, or is 4 a multiple of 3? Does 3 times something gives you a 4? No. Is 8 a multiple of 3, which means that 3 times something gives you 8? No. 12. Is 12 a multiple of 3? Yes. Because 3 times 4 will give you 12. So this becomes our least or lowest common multiple or denominator in this case. So we're going to use 12. So 12 is my LCD. I'm going to write it down here. And then now I'm going to go to the problem. Now, if you remember what we did with common denominators, we know that if we are able to get a common denominator for these two fractions, and that common denominator is going to be 12, then it's going to be easy for us to solve this problem because we are going to add the top. So we want to make sure that we have common denominators. All right. Now, if you've not watched the video I made on equivalent fractions or similar fractions, please also watch that because that is going to help you out here. So the big question is that how do I change my 3 to 12? And how do I change my 4 to a 12? Now, we know that, or we should see or know that 3 times 4 will give me a 12. But you don't want to just multiply 4 by 3. Yes, that is going to give you a 12 at the bottom. And then if you multiply 4 by 3, that is also going to give you 12 at the bottom. But what is going to happen is that our fraction is going to change to that. And that doesn't help us because the value of the fraction changes. 1/3 is not the same as 1/12. 3/4 is not the same as 3/12. So this is not going to help us. And do not do that when you're solving these kind of problems. So what we have to do is that we have to apply what is called equivalent fractions. We've got to multiply each of these fractions by 1. But because we want to make sure that our denominator is going to be 12 for both fractions, we're going to multiply 1/3 by 4/4. Now remember, from equivalent fractions, 4/4 is 1. It's just 1, right? So 1 times anything is that same thing. So we are not changing anything, only that we are creating an equivalent fraction to help us solve this problem. So I multiply the top by 4 and multiply the bottom by 4. And that is how we multiply fractions. You multiply across. So I'm going to do that. So this gives me 4 on top over 12. Remember, if you reduce this fraction, it brings you to 1/3. So 1/3 is equal to 4/12. That's what this means. Now, when I go to this part, the 3/4, I know that 4 times 3 is also 12. So I'm going to multiply 3/4 by 3/3. 3/3 again is 1. So this should give me 9/12. 9/12 is equal to 3/4. It's equal. So I've not changed the fraction. I've not changed the value of the fraction. It's still the same. And now because I have a common denominator, I'm going to add the tops. 4 plus 9 is 13/12. And then I'm going to check real quick. Can I reduce this fraction? Nope. So I'm done. Boom, done. We're going to try another one. And remember, this same thing works for subtraction. Only that at the end, you have to subtract the tops. Okay, another one. So let's do 3/8 plus 1/6. Now, at this point, I'm going to say pause the video and see if you could solve this. It's okay if you get it wrong, right? You're trying. It's good to make mistakes so that you correct them. So it's okay to try it. So pause the video and then try it. And then after, I'm going to go over it. Okay, so pause it, do it. Okay, so in this problem, we've got 8 and 6 as our denominators. 8 and 6. So to find the LCD, because we don't have a common denominator, you've got to start with the 8. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and then it keeps going like that. So you've got to ask yourself, is 8 a multiple of 6? This other guy. Is 8 a multiple of 6? Nope. 8 times nothing will give you 8, right? So, boom. We go to the next one. 16. Is 16 a multiple of 6? Nope. It doesn't work. Is 24 a multiple of 6? Yes. 6 times 4 gives you 24. So these are the multiples of 6. You don't have to write them out. You see that this becomes our least or lowest common multiple or common denominator. So 24 is what we're going to use. So I'm going to write 24 here, and then I'm going to erase these. Now, we have to make sure that we change the fraction such that we're going to have common denominators of 24. But we don't want to change the value of the fraction, so I've got to ask myself, 8 times what gives me... Okay, so I've got a 24 here. I want to make sure you can see it. Okay, so 8 times what would give me 24? It's going to be 8 times 3. So I'm going to multiply the bottom by 3, multiply the top by 3. And then I go to 6. 6 times what gives me 24 is going to be 4. So I multiply that by 4 and 4. So this should give me 3 times 3 on top is 9. 3 times 8 is 24. Plus 1 times 4 is 4. 6 times 4 is 24. So now I've got common denominator for both fractions, which is 24. So I add the tops. 9 plus 4 is 13 over 24. And that's it. And that's it. All right. Another one. Another one. So let's say that we have 3/7 3/7 plus 5. 3/7 plus 5. Again, I'm going to say pause the video and then try it. So remember, 5 is a whole number, so I'm going to do 5 over 1. Anything over 1, 5 divided by 1 is 5, right? So you have to set it up that way. Now, after you set it up, you look at the denominators. Do we have a common denominator? Nope. But the thing is that we've got these two denominators, 7 and 1. Now, you know that 7 is the bigger number or the larger number. And if you want to write out the multiples of 7, 7 times 1 is 7. So 1 will go into 7 just by that. So you know that our LCD this time is going to be 7 because 1 times 7 is 7. So that's it. So LCD is 7. So the next thing to do is to make sure that I set up my fractions to both have a denominator of 7. Now, because the LCD is 7, for this one is going to stay as it is, 3 over 7 plus 5 over 1. Here, you have to change the denominator to 7. You could only do that by multiplying by 7 over 7. And that should give you 3 over 7. That will stay the same, plus 5 times 7 is 35 over 1 times 7 is 7. And that should give you 3 plus 35 is 38. And that's it. All right. Now, I want to also take another step again and then look at when you have more than two fractions. More than two fractions. So let's say that we've got 1/3 plus 3/8 plus 1/6. So this time we've got three fractions. So first look at the largest number, which is 8, and then try to use that to help you find the LCD. So multiples of 8, 8 times 1 is 8, 16, 24. And sometimes you could just look and then see that, oh, you've got to stop at this point because you've seen the number 24. And you are thinking about it in your mind. Will 6 be able to go into 24 evenly? Or 6 times something gives you 24? Yes. Will 3 times something gives you 24? Yes. So 8 is not going to work. 16 is not going to work. But 24, will 24 work for all three? Because here you're looking at all three. For 8, you know that it's fine because 24, you know it's already a multiple of 8. But what about 6? Oh, 6 times 4 is 24. Boom. Oh, 3 times 8 is 24. Oh, yes. So 24 is going to be my LCD. So now I'm going to set up all the fractions to have denominators of 24. So for the first one, 1/3, I have to multiply by 8 over 8. So 8 over 8 times 1/3 plus. For 8 as the denominator, 8 times 3 is 24. So I have to multiply by 3. So I do 3 over 3 times 3 over 8 plus. Oops, plus. For 6, it's 4. 6 times 4 is 24. So I'm going to do 4 over 4. And then now I'm going to work it out. I've got 8 times 1 for this first one is 8 over 24 plus. For this one, we've got 9 over 24. And then we've got 4 over 24, like that. So you only add the tops. Yes, there are three fractions, but just add them. 8 plus 9 is 17, plus 4 is 21 over 24. 21 over 24. Now, is it possible to reduce this fraction? Yes. So I'm going to look for multiples that would go into, I'm going to look for factors that would go into 21 and 24. Will 2 do the job? Nope. What about 3? Huh. Will 3 go divide into 21 or go into 21? Yes. 21 divided by 3 is 7. What about 24? Will 3 go into 24? Yes. So I'm going to divide this by 3 and then divide this by 3. You divide by the same number. So this will give me 7 and this will give me 8. So 7 over 8. So this whole fraction or this whole problem gives me 7 over 8 at the end. Now let's quickly switch to subtraction. I already said that it's the same. You're doing the same thing with subtraction. But let's do a couple so that you understand how it works. So I've got 5/8 minus 1/3. 5/8 minus 1/3. So the first thing again is to look at the denominators. Are they common? Nope. So I'm going to find the LCD. I'm going to use 8 and write out the multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And then it keeps going like that. 3, will 3 go into 8? Or 3 times, well, 3 times something gives you 8? Nope. 3 times 16? Nope. 3 times something gives you 16? Nope. 3 times 8 gives you 24. And like I did in the LCM video, sometimes it is just good. The more you practice, you would know that, oh, with this to find the LCD, I only have to multiply 3 by 8. 3 times 8 is 24. 3 times 8 is 24. Just multiply the two denominators. So here we get 24 for the LCD. So I'm going to change these to 24. 8 times 3 is 24, so I do 3 over 3. And then 8 over 8, because 3 times 8 is 24. So this will give me, if you multiply these fractions, 3 times 5 is 15 over 24 minus 8 over 24. And that gives me 7 over 24. That is if you subtract the top. So it is pretty much the same. You're doing the same thing all through. Now, let me also try another example with 3 fractions. So let's say that we have 5/6 minus, oh, plus, oops, plus 1 over 2 minus 1/3. Wow, so I've got a plus and a minus in the same problem. Hoo-hoo, wow. That shouldn't scare you. You're still going to use the same principles. The first step is to find your LCD or LCM for the denominators. And if you look at this, the 6 is the largest. So the multiples of 6, you do 6, 12, 18. But here you don't have to go too far, because 2 will go into 6, or 2 times 3 is 6. And 3 times 2 is 6. Boom. So our least common denominator is going to be 6. Wow. So sometimes you don't even have to write out the multiples. You are just going to know by intuition. All right. So 5 over 6. Oh, we've got a denominator of 6 for the first fraction. So that I'm not going to touch it. But for this one here, you've got 1 over 2. So you're going to multiply by 3 over 3. And then here, you're going to multiply by 2 over 2. Remember, the reason why I'm doing that is to make sure that we have a common denominator of 6, 6, 6. All right, so we've got 5 over 6 plus 3 times 1 for this one is 3, and then you have 6, minus 2 over 6. So from left to right, that's how you're going to do it. Left to right, you have 5 plus 3 is 8. 8 minus 2 is 6. So you've got 6 over 6. Can I reduce 6 over 6? Yes, because you know that 6 over 6 is 1. So that will cancel out to give me 1 and 1. And then I've got 1. Yay! So that was good. So addition and subtraction, you follow the same method, right? You're doing kind of the same thing, only that you have to minus, you have to plus. And that's is the only difference. All right, let's look at this problem. We have 110 plus 3 14s plus 2 15s. The first thing we've got to do is look at the denominators. Do we have common denominators? Of course we don't. So we've got to figure out a way to find the LCD. Now, these are a little bigger numbers, so you've got to find a strategy, right? From all that we've done, you know that the largest number is 15, so you would have to write out the multiples of 15. So you have to know your multiplication table so that you'll be able to go back and then, or take your time and then get the multiples of 15. So let's start. Now, because these are little bigger numbers, you might have to do a lot of these multiples to check. Okay, so 15 times 1 is 15, 30, 45, 60, 75, 90, 105. Now, you could stop here and then double check. Especially with for 10, you know that 30 would work for 10, 60, 90, these will work for 10. But would they work for 14? No. So you have to keep going. So you could always stop and then double check if some of these numbers will work or one of these numbers will work. But it's not working. So you have to keep going. So 120, will 120 work for for 14? No, it's not going to work. So you have to keep going. 135, 150, 165, 180, 195, 210, 210. You have to keep going. So at this point, I'm going to double check again. 135, no, 14 times something will give you one. No, it's not going to work. 14 and then 150, no, it's not going to work. 165 and 10, nope. 180, remember you're doing for all these three, so you've got to check 10 and 14. 165, nope. 180 is going to work for 10, but it's not going to work for 14. 195, nope. 210 will work for 10. Would it work for 210? For 14? Yes, it's going to work. Wow. So the LCD is going to be 210. Now, sometimes you could create your own shortcuts to this. And what I mean by that is, you could say that, oh, I've got three numbers. What about multiplying two of them and then check, like multiplying 15 and 10? And then check if it's going to work for the three, if it's going to work for 14. Now, 14 would not go into 150 evenly, so you know 150 would not work. But what about multiplying 14 and 15? So you've got to go to your calculator and then check that what is 14 times 15? Oh, 14 times 15 is 210. And then will 10 go into 210 evenly? Yes. So instead of writing out all these multiples, I could have done that. Just multiply two of them and then check if the third one would also work with that number, and then you should be fine. Okay, so our LCD is 210. So now I'm going to go back to the problem and then try to get a common denominator. So 10 times what gives me 210? 10 times 21. So 21 over 21. 14 times what gives me 210? We already said it's 15. So 15, 15. And then here is going to be 14 over 14. Now you multiply 21 times 1 is 21. 21 times 10 is 210. Plus 15 times 3 on top is 45. 15 times 14 is 210. 2 times 14 is 28. 15 times 14 is 210. So now you know that you've got a common denominator. So you've got to add the tops. So you're doing 21 plus 45, which is 66, plus 28, which is 94. So I've got 94 divided by 210. Now I have to check if I can simplify it to its lowest term. Now 94 is an even number. 210 is an even number. So I'll probably say that I'm going to start with a 2. So 2 will go into 94, or 94 divided by 2 should give me 47. And then 210 divided by 2, that should give me 105. 105. So at this point, you are done. 47 divided by 105. And that becomes your final answer. So keep practicing these, and yeah, the more you practice, the more confident you get. All right, thank you.